Welcome back, everyone, to the deep dive. When you start digging into larger and larger data sets, you kind of hit this wall, the basic SQL stuff. It's just not enough to unlock all the really interesting insights hiding in the data.
Yeah, it's like you've learned the alphabet, but you're trying to write a novel. The building blocks are there, but you need more sophisticated tools and techniques to construct something truly powerful.
That's exactly what we're diving into today. Advanced SQL techniques to help you go from basic querying to really unlocking the full potential of your data.
Absolutely. Think of it as leveling up your SQL skills. We'll be exploring some of the techniques that separate the casual SQL user from someone who can tackle really complex data challenges.
So what are these secret weapons of the SQL world? We're going to focus on three key areas that come up all the time when you're dealing with sophisticated data: recursive queries, common table expressions, and window functions.
And the really cool thing is how these techniques build upon each other. We'll start with the fundamentals of each one and then show you how to combine them for some incredibly powerful data analysis.
I'm excited to get into it. Let's start with recursive queries. I remember when I first encountered this term, it sounded super intimidating. But once you break it down, the core concept is actually quite intuitive.
Right, it's not as scary as it sounds. Basically, a recursive query is a query that refers back to itself. It's like a loop within your SQL code.
But why would we even want a query to do that? It sounds like it could go on forever.
Well, there are safeguards in place to prevent infinite loops. And the real beauty of recursive queries is how they excel at working with hierarchical data.
Hierarchical data, like an org chart where you have employees reporting to managers
hmm
who then report to higher level managers.
Exactly. Or think about product categories on an e-commerce site where you have main categories, subcategories, and even sub-subcategories. It's data that has this natural tree-like structure.
Ah, I see. So traditional SQL queries struggle with this kind of data because they're not designed to traverse those relationships level by level.
Right. With a standard query, you might be able to go one or two levels deep. But as the hierarchy gets more complex, your query becomes incredibly messy and inefficient. Recursive queries, on the other hand, handle these situations gracefully.
Okay, so I'm starting to see the value here. But how does a recursive query actually work? How does it know when to stop referring back to itself?
Every recursive query has two essential parts: the base case and the recursive case. The base case is your starting point. It's the initial condition that the query looks for and satisfies. It's kind of like the root of the tree.
Got it. And the recursive case.
That's where the magic happens. The recursive case takes the results of the previous iteration of the query and builds upon them, essentially going one level deeper into the hierarchy.
So in each iteration, the recursive case is looking at the data that was generated by the previous iteration, and it keeps going until it reaches a point where there's no more data that fits the criteria.
Precisely. And there are mechanisms in place to make sure it doesn't fall into an infinite loop.
I think I'm starting to get it, but I'm a learn by doing kind of person. Can we walk through an example so I can see this in action?
Of course. Let's go back to that employee manager scenario. Let's say you have an employees table with columns for id, name, and manager id.
All right, and our goal is to find all the employees who report, either directly or indirectly, to a specific manager.
Exactly. Let's say that manager has an id of 1. We can construct a recursive query using something called a common table expression, or CTE, to make this whole process much more readable.
A CTE. You're jumping ahead a bit, aren't you? We haven't gotten to those yet.
You're right, I got a little excited, but trust me, they're incredibly useful, especially when dealing with recursive queries. Think of a CTE as a temporary named result set that exists only within the scope of a single query. It's kind of like creating a virtual table that you can then reference later on.
Okay, so it's a way to organize and break down our query into smaller, more manageable pieces.
Precisely. So for our recursive query, we'd start with recursive, followed by the name we want to give to our CTE, let's call it employee hierarchy.
With recursive employee hierarchy, AS. And then what?
Inside the parentheses, we define the base case and the recursive case, separated by union all.
Okay, so for our base case, since we're starting with a specific manager with an id of 1, we want to select their information from the employees table, right?
Exactly. The base case would look something like this. Select id, name managered from employees where ed x 1. This gets the ball rolling.
And then union all to combine that with a recursive case.
Right. Now, the recursive case is where we join our employees table back to the employee hierarchy CTE that we're building.
So we're referencing the CTE within its own definition. That's the recursive part, right?
Absolutely. We want to find all employees where their manager mass matches an E that's already in our employee hierarchy. So it'll look something like this. Select E ID, E.name, E managered from employees E, inner join employee hierarchy, AN, E manager equals A at AID.
Wait, so the first time this recursive case runs, it finds all the direct reports of our initial manager because they're managered as one.
Exactly. And then the next time it runs, it finds the direct reports of those employees and so on until it reaches the bottom of the hierarchy.
Wow, that's pretty clever. And then to actually see this complete hierarchy that we've built, we just do a simple select from employee hierarchy.
You got it. The CTE encapsulates the entire recursive process, and we just query that CTE for our final results.
Okay, I'm starting to really appreciate the power of recursive queries, but I can also see how they could get pretty resource intensive, especially with a massive organization.
That's a great point. One of the most important things to remember about recursive queries is that they can be quite demanding on your database. You need to use them strategically. Think of them as a scalpel, not a chainsaw.
A great analogy. Use them with precision for specific situations where they're truly needed. Don't overdo it.
Exactly.
All right, let's move on to CTEs. You kind of threw me off earlier by mentioning them before we even got to recursive queries, but now I think I'm ready to dive in a little deeper.
All right, let's break it down properly this time. As I mentioned earlier, a CTE, or common table expression, is basically a temporary named result set that you can define and reference within a single SQL query.
Okay, so it's kind of like creating a temporary table, but without actually creating a physical table in the database.
That's a good way to think about it. It exists only for the duration of your query. And one of the main benefits of using CTEs is they can make your SQL code much easier to read and understand, especially when dealing with really complex queries.
How so?
Imagine you have a query with multiple nested subqueries. It can quickly become a tangled mess. CTEs let you break down that complexity into smaller, more manageable chunks. You define each step of your complex logic as a separate CTE, give it a descriptive name, and then you can reference that named result set later in your main query, or even in other CTEs.
So instead of having a huge monolithic block of SQL code, we're creating these named modular components that represent specific parts of the overall logic.
Exactly. And this modularity not only improves readability, but also makes your code much easier to maintain and debug. If you need to make a change to a specific part of the logic, you can isolate it within its own CTE without having to unravel the entire query.
Okay, I see the value there. So how do we actually define and use a CTE within a SQL query?
It starts with the with keyword. Then you give your CTE a name followed by the keyword AS and enclose the actual query that defines the CTE in parentheses. Think of it as a mini select statement that creates this temporary result set.
Okay, can we walk through a simple example just to solidify this?
Sure, let's say you have an employees table and you want to find everyone who earns a salary above $100,000. You could define a CTE called, say, high earners like this. With high earners, a select name, salary for employees where salary $100,000.
So that select statement inside the parentheses defines the data that will be in the high earner CTE.
Exactly. And then, in your main query, you could simply select from high earners to retrieve the names and salaries of those high earners.
So instead of having that entire select statement embedded within a larger, potentially more complex query, we've now given it a name and made it much more readable and reusable.
Right. And you can have multiple CTEs within a single query, each building upon the results of the previous ones. You can even reference CTEs within other CTEs. It's a really powerful way to structure and organize your SQL logic.
I like it. It's like creating your own custom building blocks for constructing your queries.
Exactly.
Now, you mentioned earlier how CTEs can be particularly useful when working with recursive queries. I'm starting to see the connection there.
Right. When you're dealing with hierarchical data, recursive queries can be quite complex. CTEs help to encapsulate the recursion logic and break it down into more manageable steps, making it easier to understand and maintain.
Can you give me a more concrete example of how they work together?
Sure, let's go back to our online store example. Remember we talked about finding all subcategories under a specific parent category?
Yeah, that was a perfect example of using a recursive query.
Exactly. Now imagine you want to first find the ID of a category based on its name, and then use that ID as the starting point for your recursive query to find all its subcategories.
Ah, so we're adding an extra step to dynamically determine the ID of the starting category.
Precisely. You could use a non-recursive CTE to find that category ID based on its name, and then your recursive CPE would reference that ID in its base case.
So our first CTE might be something like with target category as. So select EID from categories where name electronics. This gives us a CTE called target category that contains the ID of the electronics category.
And then our recursive CTE, category hierarchy, would use that ID like this. With recursive category hierarchy is select EID name, parented from categories where EID select it from target category, union all.
I see. So the base case of our recursive CTE now references the target category CTE to get the correct starting ID, and then the recursive part of the query does the rest.
It's a really elegant way to combine these techniques and make your SQL logic more modular and reusable.
It's all about breaking down complex problems into smaller, more understandable pieces.
Exactly. And remember, the real power comes when you combine these techniques with window functions, which we've talked about in a previous deep dive.
That's right, window functions. For those who might not recall, can you give us a quick refresher?
Of course. Window functions are a way to perform calculations across a set of rows that are somehow related to the current row without actually grouping those rows into a single summary row.
It's like having a sliding window that moves over your data, allowing you to perform calculations on a specific subset of rows relative to the current row.
A great analogy. And the beauty of window functions is that they can be used in conjunction with CTEs to perform even more advanced analysis.
Can we see an example of how this might work in practice?
Absolutely. Remember our example of calculating cumulative salary by department?
Yeah, we used a window function with a partition Y clause to perform that calculation.
Right. Now, imagine you want to first calculate the cumulative salary, and then you want to identify the departments where the cumulative salary exceeds a certain threshold.
So we're adding an extra layer of analysis on top of the cumulative salary calculation.
Exactly. You could use a CTE to encapsulate the cumulative salary calculation using the window function.
Something like with department salaries as select department salary, SM salary, over partition by department order by salary as cumulative salary from employees.
That's it. And then in your main query, you can simply select from the department salary CTE and filter the results based on the cumulative salary.
So our main query might look like this. Select from department salaries where cumulative salary 100,000 first. This gives us a list of all departments where the total salary of all its employees exceeds $1 million.
Exactly. The CTE allows us to perform the cumulative calculation first and then use that result for further analysis.
I'm starting to see how combining these techniques can really unlock some amazing possibilities. It's all about layering those SQL tools to create exactly what you need.
And remember, the pro tip here is to really recognize the analytical power that window functions offer, and to understand how CTEs can provide you with enhanced flexibility in how you structure and manipulate your data both before and after applying those functions. They truly are a potent combination for tackling more sophisticated analytical tasks.
So far, we've been talking a lot about these techniques in a somewhat abstract sense. But I think it's time to bring this down to earth with some real-world examples to really see how these techniques are applied in practice.
Agreed. Sometimes seeing these concepts in action within a familiar context really helps solidify the understanding.
Let's stick with that online store example. As we mentioned before, it's a perfect domain for illustrating these advanced SQL techniques.
Absolutely. E-commerce databases often have to deal with complex product catalogs, track sales performance, and manage customer data.
Let's revisit that. Find all subcategories under a category scenario. In a real online store, this is absolutely crucial for website navigation and product discovery. Customers need to be able to browse through categories and subcategories to find what they're looking for.
Right. A well-organized product catalog is essential for a good user experience. And internally, this kind of query can be used for all sorts of things, like applying discounts to an entire category or analyzing sales trends within a specific product segment.
So using a recursive query, as we detailed earlier, allows us to efficiently retrieve all the subcategories nested under a chosen parent category, no matter how many levels deep that hierarchy might go. It really simplifies what could otherwise be a very messy and inefficient query.
And then consider the calculate cumulative sales by product example. This is essential for understanding product performance over time. It helps you track which products are gaining traction, which ones are slowing down, and ultimately to make better decisions about inventory, pricing, and marketing.
And we can accomplish this by combining a CTE with a window function.
Right. Exactly. You could have a CTE called product sales that selects the relevant data from your sales table, like producted, sales date, and sales. Then within that CTE, you'd use a window function with some sales over partition by producted ordered by sales date to calculate the running total of sales for each product.
So the partition by producted ensures that the cumulative sum is calculated separately for each product, and order by sales date makes sure it accumulates chronologically.
Exactly. And then you could further enhance this by adding filters to your main query to focus on specific time periods or to identify products that have reached a certain cumulative sales target.
These two examples really highlight how these advanced techniques can be applied to solve very practical business problems. They go way beyond simple data retrieval and into the realm of real data analysis and insight generation.
Absolutely. And I think it's important for our listeners to understand that these aren't just theoretical concepts. They're tools that are used every day by data professionals around the world to solve real problems.
Now, many of our listeners are probably also interested in how these advanced SQL concepts are tested in technical interviews. So let's shift gears a bit and look at some typical interview questions that you might encounter.
Yes, let's get into that. Technical interviews can be challenging, and being prepared for the types of questions they might ask about these advanced concepts can give you a huge advantage.
Let's start with a basic one. What is a recursive query, and when would you use it? As we've thoroughly discussed, a recursive query is a query that references itself, typically used for working with data that has a hierarchical or tree-like structure, like our employee manager or product category examples.
Right. A clear, concise answer like that demonstrates that you understand the core concept. Another question you might get is, what is a common table expression, CTE, and how does it work?
And the answer there is, a CTE is a temporary named result set defined within a SQL query, allowing you to break down complex logic into smaller, named steps.
Precisely. Being able to articulate that you understand the temporary and named aspects of CTEs is key.
Okay, how about this? How do you create a recursive CTE?
You would explain the basic syntax, highlighting the with recursive clause, the base case, the recursive case, the union all operator, and the final select statement.
Right. And it's important to emphasize that you're selecting from the CTE itself within its definition. That's what makes it recursive.
Agreed. Now here's a common one that often trips people up. What is the difference between a CTE and a subquery?
This is a good one to really highlight the benefits of CTEs.
Exactly. You'd want to point out that a CTE is defined at the beginning of a query and can be referenced multiple times throughout the query, while a subquery is typically nested within another query and isn't reusable in the same way.
And CTEs generally make your code much more readable, especially when you have complex queries.
Absolutely. Here's another practical one. How do you calculate a running total using a window function?
You'd want to explain the syntax using L over order by, and emphasize the importance of the order by clause within the over clause for determining the sequence of the running total.
Right. And you could even provide a simple example like calculating the running total of sales ordered by date.
Okay, let's go back to our hierarchical data. How would you answer this question? How would you find all employees under a specific manager using a recursive query?
You'd walk them through the structure of the recursive CTE, explaining the base case where you select the initial manager and the recursive case where you join back to the CTE to find all employees reporting to managers already in the result set. And of course, you'd need to explain the union all operator as well.
I think walking through a concrete example with a sample table structure is really helpful for this one.
Definitely. Here's another important question about window functions. What is the purpose of the partition by clause in a window function?
The key here is to explain that the partition by clause divides the data into separate partitions or groups, and the window function operates independently within each partition.
Right. A good example would be calculating a rank within each department using partition by department.
How would you go about calculating the cumulative sum of sales by product?
Similar to the running total question, but you'd want to highlight the use of partition by producted to calculate the cumulative sum separately for each product.
And don't forget to emphasize the order by clause as well.
Right. Whether it's by date or some other logical order, that's crucial for determining the sequence of the cumulative sum.
What is the difference between union and union all? This one comes up a lot, even outside of the context of recursive queries.
You'd need to explain that both combine the results of multiple select statements, but union removes duplicate rows while union all retains all rows, including duplicates.
And in the context of recursive queries, union all is usually what you want.
Exactly. You typically want to see all the steps in the hierarchy, even if some rows might appear multiple times.
Okay, how about this one? Are there any specific techniques for optimizing a recursive query?
Performance is always a concern with recursion. Here, you'd want to mention the importance of appropriate indexes, especially on the columns used in the join conditions. And you might also discuss ways to limit the depth of the recursion to prevent runaway queries.
What is the difference between a CTE and a temporary table? This one often causes confusion as well.
A good answer here would be that a CTE exists only within the scope of a single query, while a temporary table persists for the duration of your database session, allowing you to reference it in multiple queries.
And you might also point out that temporary tables are actual database objects, while CTEs are more like virtual constructs.
Exactly. Let's move on to some more advanced window function questions. How would you approach this? How would you calculate the rank of employees based on their salary within each department?
This is where you'd bring in the rank window function along with partition by department and order by salary to perform the ranking within each department.
And you could extend this question by asking how to find, say, the top 3 highest paid employees in each department.
Which would involve filtering the result set based on the calculated rank.
Oh.
Okay, how would you find the top 3 highest selling products using a window function?
This one is a bit tricky, but you can use a combination of window functions and subqueries, or perhaps a CTE for better readability, to first calculate the total sales for each product and then rank them. Then you'd filter based on the rank to get the top 3.
A great example of combining multiple concepts. How would you calculate the moving average of sales over the last 7 days? This one tests their knowledge of using window functions with frame clauses.
You'd explain how to use a window function like AVG with a frame clause that looks back over the previous 6 days and includes the current day.
Right, and you could use a clause like rows between 6 preceding and current row to define that window.
Exactly. And to wrap things up, let's go back to CTEs. How would you answer this question? Can you provide an example of how you might use a CTE to simplify a complex query?
I think a good approach here would be to provide a specific example. Maybe a scenario where you need to identify customers who have made a certain number of purchases within a specific time period. You could use a CTE to first calculate the total purchases for each customer and then filter based on that result.
That's a perfect illustration of how CTEs can be used to break down complex logic into more manageable steps, making your SQL code much cleaner and easier to understand.
Okay, now that we've gone through some common interview questions, let's put this knowledge into practice with a couple of scenario-based questions. These really require you to think about how you would apply these techniques to solve practical problems.
This is where you get to demonstrate not just your understanding of the syntax, but also your ability to think critically and apply these tools effectively.
All right, scenario 1. Imagine you have a table of product categories where each category can have a parent category, creating a hierarchical structure. How would you write a SQL query using a recursive CTE to find all subcategories under a specific category given its ID?
This one takes us back to our earlier discussion of recursive CTEs. You'd want to explain how you would define the base case to select the initial category based on its ID, and then the recursive case to join the table back to itself, finding categories whose parent ID matches an ID already in the results set.
And it's important to emphasize the use of union all to combine the results of the base case and the recursive case.
Definitely.
Okay, scenario 2. You have a table of daily sales records for different products. How would you write a SQL query using a window function to calculate the cumulative sum of sales for each product over time?
This is where you demonstrate your knowledge of window functions with partitioning. You'd explain how to use sum sales over partition by producted order by sales date to calculate the cumulative sum, highlighting the importance of both the partition by and order by clauses.
It's helpful to also mention that the final result set will include the individual sales records for each product, along with their corresponding cumulative sales up to that point in time.
Right. These scenarios really challenge you to think through the problem and apply the right techniques in the right way.
They're great practice for both technical interviews and for real-world data work.
Absolutely.
Well, that brings us to the end of our deep dive into the world of advanced SQL techniques. I hope you found it as enlightening as I did.
It's amazing to see how much power SQL gives you when you move beyond the basics.
We started with recursive queries for untangling those tricky hierarchical relationships, then moved on to CTEs for bringing order and clarity to complex queries.
And then we saw how combining those with window functions really opens up a whole new level of analytical capabilities.
It's about taking your SQL skills from basic data retrieval to sophisticated data manipulation and analysis.
It's like going from building simple structures to constructing intricate masterpieces.
I love that analogy.
Yeah.
And in our next deep dive, we're going to shift gears a bit and focus on another crucial aspect of working with databases: database security and user management.
We'll be exploring the fundamental principles and best practices for protecting your data, managing user accounts, and controlling access to your valuable information.
It's a topic that's essential for anyone working with databases, whether you're a developer, a data analyst, or a database administrator.
So we definitely encourage you to join us for that important discussion.
As always, we'd love to hear from you. If you have any questions about what we covered today, or if there are other topics you'd like us to explore in future deep dives, please feel free to reach out to us through our website or on social media.
Your feedback is invaluable to us. It helps us create content that's truly relevant and engaging for you.
So thank you for joining us on this deep dive. We hope you've gained some valuable insights that you can apply in your own work.
Keep exploring the fascinating world of data. What's truly remarkable is how mastering these advanced SQL techniques unlocks the potential to discover so much more within the information we work with.